In the previous lesson, we were introduced to the data management process or the data management issue, and as part of the definition of data management as we will view it was the reference to a workflow process. What we will look at in this lesson is an example of that process so that you are able to better understand what we mean in terms of a workflow, and then also be able to see that this is a process that must be followed. It does contain a series of steps, and in some cases consists of checks and balances to help ensure that the data that we're working with is of high quality, at least with regard to the possible inclusion of human error in the inputting of the data. Now, if we take a look at this particular chart, essentially what we do at the beginning is simply identify the data source. And recall from the previous video that and for our purpose right now, data source simply means, are we working with some form of hard copy data that we as the researchers will have to transfer into electronic format, or are we going to in some form or fashion obtain data that's already in an electronic format. Now, again, electronic data collection could be that we are working with data that was collected by other researchers, and we're simply obtaining a copy of it through whatever procedures are appropriate. Or it could be that we're actually collecting the data, but we're using tools such as SurveyMonkey that will collect the data. Once it's collected, then we can actually download the data in an electronic format. So in some form or fashion, the electronic data collection is just simply meaning that when we get the data, it's already saved, it's in electronic format. We will not have to do any manual data entry in order to begin working with our data. Now, again, if we look at the workflow, essentially what we have are three possible options. For example, under the data source, if we determine that for our particular purpose, we're going to have to work with a manual data entry process, then we would begin by coming down and over to the left. And if we are going to actually be handling all of the data, then in most cases we can do this directly in our word processing program. And so our first step would simply be to open whatever our software of choice will be. In our case, we're going to focus on the use of SPSS as the data analysis software, and then we will begin to enter the data. Of course, as you begin to enter the data, you do want to be familiar with how the data needs to be entered from a formatting standpoint for the type of analysis that you're going to be doing. For example, if we are comparing two independent groups, let's say we've conducted a study with a treatment and a control group in SPSS, we do not separate and put the treatment group's data in one column and the control group's data in another column. In order to conduct the t-test properly, all of the data must be placed into one column. The second column will actually be used to identify the group with which that particular score is associated. The format of the data entry we will see as we progress through the analyses at a later time. But again, it's something that you do want to be aware of what analysis you're planning to conduct, because it may impact how you go about entering your data. Now, again, because we're already in SPSS, we won't have the issue of having to save and then import and so forth. However, because we are working with manual data, we do have that possibility of human error. And so there are a couple of checks and balances that we need to address before we conclude our data management process. The first of those is to conduct random data checks for cases. Now, what this is essentially saying is if we have conducted surveys and we have 100 surveys, then one of the common practices associated with surveys is to incorporate some sort of an identification number. Now, this might be something that the patient or the individual provides. It could be some sort of number that's actually a derivative of various responses that they provided, or it could simply be a matter of when you sit down and you have collected 100 surveys, you simply write down the numbers 1 through 100 in the top corner of the survey. In a sense, the numbers are meaningless with the exception that you will also enter that number into the SPSS spreadsheet. And so when you're entering survey number 1, the first piece of information you will enter is the number 1, and then you will begin to enter their responses. The reason for this is that after we've entered our data, we could take our surveys and pull a random sample of, say, 10 or 15 surveys, and maybe we pull survey number 7. And so we could go into our spreadsheet and go down and locate the entry that corresponds to ID number 7, and we simply will look across at the values that we entered and compare those to the values that are on the survey. And basically we simply want to make sure that they match up. Now, in most cases, in the vast majority of situations, those numbers are going to match up, but occasionally we'll find that we mishit a key. Maybe if we were doing some sort of a rating scale where we have 10, 15, 20 items, at some point we might have gotten finger happy, and all of a sudden instead of typing a 3, we typed a 33, and so we might catch that, or we might have gotten off a line and not realized it. So again, things happen, and so what this does is just gives you a random check to see if, on a case-by-case basis, did there seem to be any discrepancies. Now, the other thing that we can do, and again, because we're already in SPSS, there's no import process, but what we would want to do at this point is conduct a simple frequency analysis. And again, keep in mind at this point we have addressed the issue of a code book, and I mentioned code books in the previous video. We've also addressed it earlier. In effect, a code book is simply taking your survey and making sure that you have numbers assigned to all of the question responses. Again, we saw this back with the scale of measurement where instead of entering male and female, we had to convert that, and we assigned a 1 and 2. Instead of entering the 4 different income labels, we had to convert those and enter a 1, 2, 3, or 4. And so that's all we mean by a code book. And so at this point, the code book issue would have already been resolved. So as we're entering data, we're actually entering the numerical values, not the actual labels. So we're not entering male, we're not entering female, but we're actually entering 1s and 2s and so forth. At this point, we would simply go and run a basic frequency for all of our questions. So if we have gender, if we have race, if we have age, we would run that check for all of our questions. And so if we conduct our frequencies and we see, for example, on gender, whoa, all of a sudden we have a 4. Well, we know that we can only have 1s and 2s, so that tells us somewhere we actually missed a key. Instead of hitting 1, we inadvertently hit 4, or we might have hit an 11. And again, because this is this is a check for the entire data set, yes, we ran the random checks, but the random check, the one that got an 11 for gender, simply wasn't one of the ones we happened to pull as a random check. So we want to run these frequencies to make sure that all of our data is clean. We don't have any values that shouldn't be there in terms of lying outside the range of possibilities. Now, once we've run the frequency check, we're confident in our data. The last step, and this will be the last step in all the workflows, will be to assign variable and value labels. Right? And as we begin to look at some of the analyses, we'll begin to see the advantage to assigning labels instead of keeping just the default values that are automatically used. So if we have manual data entry at this point, from a data management standpoint, we basically have reached the end of our workflow process. Now, as far as electronic data collection, again, with electronic data collection, we have two options. We have one option where we were provided with a delimited data file, or we have our program specific, and in this case we're going to refer to SPSS. Now, if we were fortunate enough to obtain an SPSS file and it was appropriate in the sense that we weren't going to have to collaborate, or even if we were collaborating, everybody on the team had access to SPSS, so the notion of sharing files and everybody being able to read files was okay, then it literally is simply a process: open the data, and then if necessary, use a find and replace in order to recode the data. Now, this was a step that we didn't mention in the manual data entry, but is actually one that could very well also apply to our manual data entry. I mentioned with the manual data entry, we might have had a Likert scale situation where the respondents were asked to rate something or respond strongly agree to strongly disagree. Well, in some instances, the favorable response may actually be to disagree. And traditionally, when we assign values to these numbers, and again, we'll see this at a later time, whatever is considered the inappropriate or undesirable or less favorable response, we assign the lower values. So if we have a 4-point or a 4-item scale, then we would simply assign our numbers 1 to 4 or 0 to 3, depending on the appropriateness of using 0. And so we would assign disagree to be 0, and then strongly agree or strongly disagree to be 0, and strongly agree to be 3. Again, assuming under normal circumstances agreement is what we want. But we might have come across questions where we've purposely reversed our wording so that the favorable response is actually to disagree, right? And so in that case, the 0 becomes the desired response. The problem that we have is that when we begin to conduct our analyses, especially if we're having to calculate subscales based on these responses, then we want to make sure that everything is being expressed where the high number is favorable. And so when we talk about recoding the data, what we're also referring to is reverse coding. And so we actually have to go through a process of telling the program to go in and assign make 0 be 3, make 1 a 2, make the old 2 a 1, make the old 3 a 0, so that now the interpretation, not what the response was, but the interpretation is now correct. And so again, all of this is done within SPSS. It's the simplest place for that to take place. Once all of our coding is done, again, we come down to our last step, which is assigning the value and variable labels. Now, our final workflow, and as you can see, this is going to be the one that is the most involved because we're getting data that is not formatted yet. Now, presumably, if we have an SPSS file, that SPSS file has already been given variable names, not labels, and we'll see the difference between a variable name and a variable label. But with a delimited file, that may not be the case. And so one possible workflow would be to take our delimited file and import it into Excel. Again, kind of a universal spreadsheet, and Excel handles data cleaning very well. So we can import our data into Excel. The first thing that, and again, this is sort of an if necessary, is to use a find and replace option in order to recode the data. Now, in terms of reverse coding, that's best suited for SPSS. However, what will happen frequently, especially if we use situations or programs like SurveyMonkey to capture our data or distribute our survey, is that SurveyMonkey, even though in our minds we know we want strongly disagree to be a 0 and strongly agree to be a 4, SurveyMonkey actually captures the actual response. So if we have labeled the columns in our survey strongly disagree, agree, and strongly agree, then when somebody marks agree, SurveyMonkey does not know that's supposed to be a 3, and so it simply records agree. And so when we open this file into Excel, instead of a spreadsheet that's got a whole bunch of 0s, 1s, 2s, and 3s, it's going to have a whole bunch of strongly disagrees, agree, strongly agree. And so at this point, the find and replace is really referring to the notion of replacing the wording with the numbers. And so again, this is where the code book comes back into play. Again, if we ask, for example, for gender, SurveyMonkey is going to record male, female. And so male, female is what's going to get imported into Excel. And so we use a find and replace, and we simply tell it find female, replace it with the value that we've assigned it through the code book, find male, and assign it and replace it with the number that we've assigned in the code book. So that when we finish this process, our spreadsheet in Excel will consist strictly of numbers, right? With the possible exception of the top row, which will end up being the variable names, and we'll see that later. And so once we've done the find and replace, the variable names, if they're not already there, we may have to create them. And so that's why that's in the workflow. Once we have completed this, then we can save the data. Technically, if we imported it in as a comma delimited file, we could save it and retain the comma delimited format, and then simply read that file into SPSS. But in most cases, SPSS will read Excel without any problems, and so our workflow may simply say, okay, now that we've got everything cleaned up, let's go ahead and save it in an Excel file. Right? And then we'll import that Excel into SPSS. The advantage to that, or one advantage to that, is those names that we placed in the first row, SPSS will automatically read those and place them at the top of our columns, so we won't have to recreate them. And then again, once we've gotten the data into SPSS, we simply need to go in and assign the variable and value labels, just like we did with the other two types of data entry.